Hello everyone. We are going through the chemistry guide video. This is ASA level and the topic is numbers of nucleons. This topic will be covering Cambridge, Adexel, AQA and Oxford specifications. So this is on atomic structure. These are three videos. One of the video is this one, which is on numbers of nucleons. The other two videos are on elements and atoms and inside the atom. So you'll have to go through other two videos as well, so that you can cover this complete topic, which is atomic structure. Hopefully you will understand this. So let us move to the next thing, which is atomic structure. And this will be number of nucleons. Basically, we will be discussing number of nucleons. And number of nucleons will be, if we go through the typical diagram, which is the of atom will be this one, which is containing protons, neutrons and electrons, and central part is known as nucleus. Electrons are revolving around the nucleus. So this is basically the region which are having higher probability of getting electrons, and the central part is containing protons and uh, neutrons. So the structure and properties of atomic nucleus, if we discuss first. So the atomic nucleus consists of two types of nucleons. What are those two types? Protons and neutrons. And these are known as subatomic particles. These subatomic particles have nearly identical masses. Protons and neutrons are having almost same mass but differ in their electric charge, because proton is having +1 charge and neutron is basically electrically or neutral, or you can say the charge is in balance, and are responsible for the elements identity. Basically protons are responsible for the identity of element. We are identifying elements on the basis of a number of protons it contains inside the nucleus. Now, the next thing we can discuss the relation between atomic number, mass number, and neutron number. So, if we go through this type of, for example, we have taken carbon, which is carbon 12. 12 is the mass. It's containing 6 protons, 6 neutrons, and 6 electrons. This is basically the carbon 12, which we are taking as a standard, and its atomic, we are taking its mass as 12 amu, and this is taken as standard. We are comparing other elements with the carbon 12 isotope. So this is like 6, this one is carbon atom, which is contains 6 protons, 6 neutrons, and 6 electrons. So atomic number we are representing with Z, which is number of protons. So Z is number of protons. In this case, this one 6 is Z. Then mass number, which is in this case 12, and we are representing with capital A. Keep in mind atomic number and mass number are with the capital letters. Number of protons plus number of neutrons is basically the mass number. Then we can say that A minus Z, atomic mass minus atomic number, will be giving us the number of neutrons in it. Then we can discuss the symbols in the periodic chart. Symbols we are having basically like this one, we are representing with a letter which is like this. One letter, it's an abbreviation. Basically, it can be one letter or two letters, and these are like standard. We can't change these are already fixed, so we have to follow the periodic chart symbols. And then we have this one, which is at mass number. So number of protons plus number of neutron in the atom, and Z is atomic number, which is mentioning the number of protons in the atom. So a standard atomic symbol, as we discussed, like for example, for oxygen, it is O, iron will be Fe, and sodium will be Na. So these are like in letter code. These letter codes are international, derived from the elements. It can be English letter, English words, or Latin or Greek. So these are different from different languages we scientists have taken. So the format is what? First letter always uppercase. So first letter will be always capital, like mg we will be writing m capital and g will be small. So second letter is if present always lowercase. So like for example calcium will be ca, like this one. So first letter will be capital, second letter will be small. Then like copper, this one copper example we can take, which is from the Latin word, which is cuprium basically. And then atomic number we are representing with Z, and the number of protons in the nucleus of an atom is known as atomic number, and the location is subscript on the left side, this one Z. Then significance defines the elements. Atoms of the same element have the same Z, and like for example, sodium, it's always sodium like 11. Then we can discuss the other like mass number also. Mass number is represented by A, which is containing number of uh, protons and neutrons inside the nucleus, and this is like superscript on the left side. Here we have mass number. So significance is identifies the specific isotope of an element. Like sodium, this isotope of sodium has 11 protons and 12 neutrons also. Then ionic charge also, we can have positive charge, positive ion, or negative ion. We can have positive or negative ions. And the charge on an ion indicating loss or gain of electrons. When an atom is a neutral particle, so whenever it is losing one electron, it's switching to a positive ion, and if it is losing it's gaining electron, it will be changing to negative one. So superscript on the right side we are mentioning over here, like this one. If it is like lithium, so it will be +1, or sodium will be +1, like this one. So format number will be first. If 2 plus 1, we can just write like this. If it is 2 positive 2, so we can write +2 like this one. So or plus minus whatever 1 like this is written as just. So plus minus 1 we can just write as plus or minus. So sodium ion will be also oxide. And isotopes, we can discuss isotopes. What are the isotopes? Isotopes are basically atoms of the same element, having same number of protons but having different number of neutrons. So we can discuss atoms like hydrogen, 1h1, 1h2, 1h1, 1h2, and 1h3. This is protium, deuterium, and tritium. Protium is having only one proton and one electron. In each one protium, deuterium, tritium, one proton, one electron, but neutron number is different. As you can see, 1h1 is having no neutron, 1h2 is having one neutron, and 1h3 is having two neutrons inside the nucleus. Then we can have a list of isotopes. Hydrogen we have already discussed. There are different isotopes: helium, lithium. No need to memorize, but you should know the concept of this. So these are like symbols. Then atomic number, number of protons, and number of neutrons. Your concept should be clear about this. Then isotopes are distinct nuclear species of the same chemical element. Keep in mind, isotopes are same element, but with the difference, and the difference is what? Difference is of neutron, number of neutrons. They have the same atomic number and position in the periodic chart. So positioning in the periodic chart is because of number of protons, which is same in all the isotopes of an element. So we are positioning isotopes at the same place in the periodic chart, but different mass numbers due to different numbers of neutrons in their nucleus. While all isotopes of a given element have virtually the same chemical properties, they have different atomic masses and physical. Keep in mind that chemical properties are basing on the number of electrons, and that too on majorly or mainly on the outermost electrons. Sharing and donation and acceptance of electrons is all basing on the valence electrons. So chemical properties are basing on the number of electrons, whereas physical properties are basing on the mass number of an element. We are done with this. Hopefully, you understand this. Again, you will have to go through three set of videos to cover atomic structure topic. One is elements and atoms. Second one is inside the atom, and third one is this video which we are covering, which is numbers of nucleons. By revising these three videos, you will be covering atomic structure topic of ASA level syllabus. And thank you very much for watching. Don't forget to subscribe the channel and introduce this channel to your respected teachers and recommend this channel to your friends and class fellows. Thank you very much for watching. Take care. Bye.